At its core, PHP is not a language that allows multi-threading or concurrent code execution by default. However, there is a simple trick that allows you to run at least some code concurrently in every application, with the potential to reduce the response time significantly. In this video, we are going to look at how to execute multiple HTTP requests concurrently using Symfony's HTTP client with an example right from our Tideways codebase. Moin, I'm Benjamin, and my work is focused on PHP performance topics for the last 10 years, helping thousands of developers, companies, and open source projects along the way. PHP runs requests concurrently utilizing Apache or PHP FPM, but they are completely separated from each other and they don't share state with each other. If you want to reduce the amount spent processing in a single script, then there's no built-in way to execute multiple SQL queries at the same time or render different parts of the HTML output in multiple threads and then merging them. But for a long time you can run HTTP requests in parallel using the curl extension. And if you do this strategically in your application, you can get it faster as a result. For example, by spreading expensive work out to a backend service or to microservices, you can compute them in parallel. Before we get to the code, if you like to stay informed about PHP performance topics, I would really like to see you subscribing to this channel or our newsletter. The link is in the description. We are going to look at an API in our codebase that fetches data for traces and call graphs from a remote storage server. The API is called Profile Network Gateway, and it finds binary data for a profile on this storage servers. The storage servers are sort of a distributed SQLite system where every customer has SQLite databases of traces, and we store them in multiple servers for redundancy and for when one of the servers goes down. So then when we query the data for one of the traces that you're looking at, we need to iterate over all of the storage servers and query them for this data. And sometimes one of the storage servers doesn't have the trace because we don't store it on all of them, only on a few of them. So this system is rather simple. You could probably have a much more clever approach to do this, but our performance constraints here are still very fine, so it didn't cause any problem to do this so far. What we can do, however, is if we have 3 storage servers, for example, we can call out to them in parallel and ask them, do you have this trace payload or not? And then we can fetch them concurrently at the same time and look which of the requests returned a result and then use that. So what do we have here? We iterate over the storage host IPs, then using the Symfony HTTP client, we query the remote storage. For a response, we ask for the response code, and then if we find something, we return sort of a value object of this data. So it's really binary, so we need to uncompress it and JSON decode it, and then that turns into this binary profile data type. So if we look at how this looks in sort of a trace displaying the events and how they occur, we can see on our dev system, which I'm working on here, that we have the controller raw trace data action being called, and it makes 3 HTTP requests to this local API here, which is this trace storage server. They are not run in concurrency, they are run right next to each other or behind each other. So we can see the first one returns a 404 not found result, the second one also, and then the third one returns a result. So this here is really expensive HTTP calls that if we run them concurrently, we could avoid this hit in the code. So how we do this with a Symfony HTTP client. And this is where I like the Symfony HTTP client actually, because it's so simple to make APIs concurrent. Let's look at the documentation. There is a section about concurrent requests here. Symfony's HTTP client makes concurrent requests by default. This means you don't need to configure anything special to send multiple requests in parallel and process them efficiently. So I believe Guzzle is also the same. So I haven't looked at Guzzle for a while and doing this. Guzzle has also an excellent API about concurrent requests, but we are using Symfony in our code base, so the HTTP client comes in handy. How does it work? So here we see we iterate over a list of things, and then we make a GET request to an URL here, and we store the responses. And then we iterate through the responses and read their content later. So how does it look in the code that we have looked at, which doesn't run in parallel? So going back, we see we create the response, but we immediately ask for the status code. And this is a blocking call in Symfony's HTTP client. So at that point, it waits for the request to end. And this is why we see them running after each other. So let's rework this code a little bit. We introduce an array of responses, and then we sort of duplicate this for each a little bit. So we store the request and the responses here. Then we iterate over the responses, and then we query the status code here and do this work here. So instead of we need to remove this block here. So first we gather all responses, and then we iterate over them and ask the first one for the status code, and this should make the request run concurrently. Let's see. So let's see how this looks in a trace and if the concurrency is now visible. We run the Chrome extension on this endpoint because this is the one that has this parallel request. So it reloads the page using a secret value and gathers the profiling data. We can select the raw trace data action from the list of resulting queries. Then we can see here, it looks a little bit different than before. We see one span here, and this user interface is a little bit funky with parallelism. But if we switch to the core graph, then we can see here that we have the HTTP calls running concurrently, and one of them is completed and the request is ending early. And we've implemented a very simple performance optimization using the Symfony HTTP client and its way of concurrently making HTTP requests. As you can see, it is rather simple to use the Symfony HTTP client and also to use Guzzle to implement this kind of performance optimization in your code. If you have a central user interface that a lot of users are using and there's a lot of performance spent in this single endpoint, then you can think about how can I rework this to get some or all of the data from a backend service, a second service I talk to, and this one I call in parallel using my HTTP client. Obviously, you need to scale out for this service. So when one user request makes, let's say, 5 requests to this backend service, then you need to have the scale available to do this. So if you have 100 concurrent users, then this backend service needs to handle 500 concurrent HTTP requests. So it's a question of making this scale possible to reduce the response time of the application by a large amount of time. If you find this or other topics about PHP performance interesting, I would really like to see you subscribe to this channel or to our newsletter. The link is in the description. Bye!